Welcome to Curie Electronics. In this video, we are going to solve IPRC Technician B Electronics question paper. The exam was conducted on 10/04/2022. So there were total 60 questions. And this is a set D question paper. For the truth table of the given figure, y equal to what? What is output y? So we have three variables, that is ABC. With the Carnot map, we can simplify easily. It's a three variable Carnot map. So this is, we can write it as A bar, B bar, A bar B, or let me divide here also. Okay, A bar B, A B, and finally A B bar. And here it is C bar and C. Now where and all we are having outputs, that is A equal to B equal to C. All inputs are 0, output equal to 1. Next is 0, 0, 1. 0, 0, 1. And next here, that is 1, 0, 0. 1, 0, 0. And 1, 0, 1. 1, 0, 1. So remaining all are zeros. So what we can do, we can fold it. When we fold this, we will get a chord, a group of four variables. Then what happens, two variables will get cancelled. So here C and C bar will get cancelled. Then A bar, B bar, A B bar. So finally B bar will be the answer. So y equal to B bar. Right here, see here, A bar, B bar, from the last one, A, B bar. So A bar and A will cancel. B bar is the answer. So which is the option? B bar. Option D is the right answer. Option D is the right answer. Let's go to the next question. For proper operation of the transistor, its collector shall be the collector. Proper operation means to use the transistor in active region, that is reverse bias. The circuit that provides the best stabilization of the operating points is, that is the potential divider bias. Potential divider bias means we have a transistor, collector there going to be one resistor, that is RC, and this is the VCC. Then to the base there is a potential divider that consists of R1 and R2. Here also we will have one resistor, and this biasing provides stabilization, good stabilization. So it is a potential divider bias. Question number 4. If the maximum collector current due to signal alone is 4 milliamps, then zero signal collector current should be at least equal to, it should be 4 milliamps is the answer. 4 milliamps is the answer. That is zero signal collector current, zero signal collector current should be at least equal to, or greater than, it should be zero signal collector current should be equal to or greater than maximum collector current maximum collector current due to AC signal alone. That is the condition. So it should be at least equal. Question number 5. 1 coulomb is equal to the charge of, that is equal to 6.25 multiplied by 10 to the power 18 electrons. The charge of so many electrons is 1 coulomb. So the answer is option B is the right answer. 6.25 into 10 to the power 18 electrons. Question number 6. When a differential amplifier is operated single-ended, how it is configured? That is the question. So differential amplifier means we will have a similar type of transistor, 2 transistors, and there will be both the emitter will be connected to a resistor, and the collector will go to VCC, and the output is taken here across the collector. And now what about the input? When you use it as a single-ended, one input should be grounded. This is one input, okay? And this should be grounded if you are using as a single-ended. And the other input, this is the second input. This is also input. Second input, input 2. Input 2 we can say. And here we will apply the signal. So what is there in the option? In the output is grounded. No, one input is grounded and signal is applied to the other. Both the inputs are grounded. The output is not. So the answer is option B is the right answer. One input is grounded and the signal is applied to the other. So thus here we are getting the output. Single phase AC power has voltage peak at. Single phase AC power means just like a sine wave. Okay. So where and all is having peak here and here for a full cycle. This is 90 degree. And here it is pi, that is 180 degree. And after that we have to add 90 with 180 degree. 180 plus 90, 270 degree. That means answer is option A, between 90 degree and 270 degree. No, not between, at that points. Single phase AC power has voltage peaks. The peaks at 90 degree and 270 degree. Question number 8. In wires, increase in gauge number means, that is there, no? If we say AWG or AWG 24, then we will say AWG 25. AWG 25. This is the gauge number, okay, 25. And AWG 26. See, when the gauge number increases, actually what is happening? Diameter decreases. Circular area also decreases. So the answer is option B is the right answer. Circular area decreases and diameter decreases when the gauge number increases. In transistor, dash controls the flow of current carriers from emitter to collector. It is base. Base is the answer. Why? Because our base current is controlling in the collector current and emitter current. The current between collector and emitter is controlled by the base current, IB. In the maximum voltage VEB, that can be applied across base emitter junction in BC148 transistor. That is, if you see the data sheet, it is 5 volt. 5 volt is the max VEB. Question number 11. The current gain alpha of a common base amplifier is, see, alpha we know, common base amplifier, and it is always a less than 1. Less than 1 alpha. Alpha is less than 1. What is the alpha? Because base is common. That means it should be IC upon IE. I think it is IC upon IE, alpha. Next, or IE upon IC, little doubt. I think IC upon IE. So, but it is less than 1. Alpha value of alpha is always less than 1 because it can go up to 0.999, but not 1. Less than 1. Question number 12. In the given circuit, which is emitter follower? Which is emitter follower? Okay. In emitter follower, what happens? We will take the output from the emitter terminal. So option B is the, figure B is the right answer. That is this one. Because we are, in emitter follower, we will take the output from the emitter. So here only, this place only we are having the emitter output. That is a figure B. So that is the right answer. In the following figures, which symbol represents moving coil with thermal converter isolated? I actually don't know what it is. It's a moving coil, I understood, but the right answer is option B is the right answer for this. Question number 14. In carbon zinc cell, which material is used as cathode? See, the carbon zinc cell means what? It's a dry cell. Okay, this is the same as the dry cell, whatever 1.5 volt cell we purchase from shops. And here the cathode is the zinc. That cover of that cell is the zinc. That is called zinc can. Zinc. This is the cathode. And anode is the carbon rod. Carbon rod. So the answer is option A is the right answer. Cathode. That is the zinc. Zinc can. Question number 15. When the capacitance is connected in series, the total capacitance is, that is, see, when you connect two capacitors in series, what happens? This is C1, C2, and this is the CT. What is CT? CT is C1 multiplied by C2 upon C1 plus C2. So it decreases lesser than the smallest capacitance value. The resultant will be lesser than the smallest capacitance value. Question number 16. Which of the following statement is false in series capacitance circuit? In a series capacitance circuit, what is there? Capacitors are connected series. I'll take two capacitors and we'll apply a DC source here. Then what happens? The Q is same, or we can say I also same throughout the circuit. But potential difference is different. That is Q equal to CV. V equal to Q upon C. See, if the capacitance value is less, voltage drop across the capacitor is more. So for the option D is the wrong one, because the voltage across each capacitor is same. That is not the correct statement. Question number 18. Which of the following oscillators uses positive and negative feedback? Even I did not know before, but it is Wien-Bridge oscillator. It is Wien-Bridge oscillator which uses positive and negative feedback. Question number 18. A transistor has a typical beta of what is the beta value? It is 200. Collector current IC equal to 12 milliamps. Then base current. What is beta? Beta equal to IC upon IB. Now what is the question we are asking? We have to find IB. Base current IB equal to, what is the value of IC? That is IC upon beta. So it is IC is 12 milliamps upon beta is 200. This we can simplify to 6 milliamps upon 100. Right? I'm just doing the division. So it is 0.06 milliamps. The base current is 0.06 milliamps. Yes, they are given in the milliamps only. So the answer is option C is the right answer. Question number 19. Windows. Windows, all of us know it is an operating system. It's an operating system. Database, one example of database, that is SQL. Data transfer protocol, I don't know. What is programming languages? That is C, C++, Python, Java, all these are programming languages. So the answer is operating system. Question number 20. Which amplifier gives very less distortion? That is the class A amplifier. See, for a class A amplifier, if this is the input, it's actually pure sine wave, assume it input, then we will get an output also like that, or amplified full wave we will get output. So it is distortion is less, that is class A amplifier. In the class A amplifier, maximum efficiency of a class A amplifier is 25%. Okay. Maximum efficiency is 25%. But it can be increased up to 50% by transformer coupling. That you should remember. It can be increased up to 50%. Next question. Find the power dissipation in 1 kilo ohm resistor if there is a current flow of 10 milliamps. That means we have a resistor, 10 milliamps of current is flowing through it. And what is the value? 1 kilo ohm is the resistor value. Now power, in this kind of situation you have to take P equal to I square R. What is I? 10 milliamps. So it is, I'll write it in amps. So it is 0.1. Because 10 upon 1000, I want converting into amps itself. So it is 0.01. I square R. R is 1 kilo ohm. That means 1000 ohms. Now if you multiply, what we get? We get 0.0001 multiplied by 1000. So we'll get 0.1 watt. 0.1 watt is the answer. 0.1 watt is the right answer. Option B is the right answer. Question number 22. Dash is a diamagnetic material. Dash is a diamagnetic material. Here, diamagnetic means their permeability is less than 1. And also, it won't get magnetized if you keep it in a magnetic field. The answer is mercury. Option B, mercury is the answer. This aluminium is paramagnetic. That means slightly it will get magnetic. Slightly it will get magnetized when we place this paramagnetic material in magnetic field. Then see, for a diamagnetic material, permeability, that is mu is less than 1. That is for the diamagnetic. For paramagnetic, mu is greater than 1. For ferromagnetic, it is high value, and it will get, this ferromagnetic material will get magnetized highly if you place it in a magnetic field. If the time constant is 2 tau, then capacitor will charge to 86.5%. So more suitable option is option A, 86.4%. This and all we have seen in many question papers. Also, you know how, see, it will be get charging like this. One exponential curve will get charging. So now let's move to, so if it is only 1 tau, what is the percentage it will get charged? That is 63.2% for 1 tau. 2 tau, we know 86.5%. And if it is 3 tau, how much it will get charged? It will get charged 95%. Okay, 3 tau, 3 time constant, the capacitor will get charged to 95%. Then what about 4 tau? 4 tau, it will get charged about 98.2%. 98.2%. 5 tau, generally we will consider as fully charged. So it becomes 99.3%. 99.3%. So let's move to the next question. Question number 24. Here we have to find the load regulation of the transformer. Load regulation of the transformer. See, load regulation, there are two equations. Okay, I will write one equation here. Load regulation of power supply. Okay, for power supply. For power supply, the equation is different. That is equal to V no load minus V full load upon V full load into 100. This is for the power supply, but here it is a transformer. This is not the equation needed. Here load regulation equals, the numerator is same, that is V no load minus V full load upon here V no load into 100. This is for the transformer. So if you put the values, 11 minus 10 upon 11, so into 100, what we get? 1 upon 11 into 100 to come to 0.0909 into 100. So we will get, what we get? 9.09%. This is the load regulation of this transformer. So option B is the right answer. Option B is the right answer. 9.09%. Let's move to the next question. Question number 25. PCI in computer stands for Peripheral Component Interconnect. Peripheral Component Interconnect. It is there. Component interface. Option C is the right answer. Peripheral Component Interconnect. Question number 26. If a transistor has a current gain of 0.95 in common base configuration, so that means the alpha is given 0.95. Then what will be the current gain of the transistor in common emitter configuration? That means beta we have to find out. It is simple. We know one relation. Beta equal to alpha upon 1 minus alpha. What is the value of alpha? 0.95. 1 minus 0.95. So which equals 0.95. 1 minus 0.95 equal to 0.05. Which equals, if you multiply by 100 numerator and denominator, we will get 95 upon 5, which is equal to 19. So 19 is the answer. Question number 27. Multi-vibrator which generates square wave of its own. That means we are not giving any signal to the multi-vibrator. Then it is a stable multi-vibrator. That is the free running multi-vibrator. A stable multi-vibrator means free running multi-vibrator. So it will be keep on generating the square wave. Question number 28. In the oscillator circuit with only DC power source can be produced. See, oscillator can produce sine wave, sawtooth wave, square wave, anything. Because if you think about Colpitt's or Hartley oscillator, we are not giving any signal. It is generating. Also, if 555 timer, when you mark as a stable multi-vibrator, it is also generating square wave. So, any of the above. The oscillator circuit with only DC power source can produce any of the above, whether it is sine wave, square wave, or sawtooth, anything. Question number 29. The ability of the power supply to maintain constant DC output voltage for variation in the load current is known as. See what happens when we connect a power supply to a load. With change in load, the output, the DC voltage should remain constant. That is known by the load regulation. That is load regulation. Line regulation means with the input voltage changes, that is input voltage to the power supply changes, it should take care of the output. Voltage regulation means it can be load regulation or line regulation. In this case, it is particularly for the load variation. So it is load regulation. Question number 30. Which of the following is not a peripheral device? See, if you observe here, the speaker is output device, printer is an output device, the mouse is an input device, but this modem is not an input-output device, it's a communication device. So it has to be modem should be the answer, modem. So first part we have completed. The next part, let me try. I think this week I am a little busy. Let me try. If I get time, I will try to upload the video this week itself. If you like the video, please share with your friends. Any doubt, please ask in the comment section. And don't forget to hit the like button. Also, thanks for watching.